All right. Good evening, good morning, good afternoon, good wherever you are. I am here live every Friday. We're gonna have a really great talk today. For those of you who are joining, a lot of people do watch this um, in recorded mode. I noticed that actually quite a lot. People watch it quite a few minutes, so a good lot of watch time. I really appreciate it. My goodness, I'm growing subscribers like crazy, and I appreciate anybody who's new to the channel who have been telling people about it, because this is the only channel around that really is dedicated to all the thousands of scientists actually who work outside the mainstream, who have found problems with mainstream, fixed those problems, and who have come up with new models and new theories. And you're not going to find anything like this, so make sure you do go down below, right down there. Click on the subscribe button and the little bell next to it, and you'll be alerted to like when this is live. And I can see it here, following it here, and it says live today, August 17th. And there I am with. I'm going to turn this down so I can see all. I've got all the chats and stuff. Welcome. The first person is here. Man, I think I got 10 new subscribers today. It's quite good. Again, I appreciate you. I haven't been by here. Today, I'm going to be talking about ether. Yes, the ether, luminous ether, other ethers. I would say, without a doubt, the majority of people outside the mainstream who do subscribe to model are etherists, but there are other models. And ether model's been around for hundreds of years, and there's a lot of misunderstanding about what they are, and I'm going to try to talk about that a little bit today, especially since I don't just read about it on the regular main websites. I hang out with etherists for many years. I've hung out with them for a couple decades, so I appreciate everybody coming by tonight. Hey, there he is, Greg Stewart. Nice to see you. You guys got any questions? Especially, it's going to be. I'm going to be talking about ether, but of course, I will answer questions. And I do try to watch those questions here, and again, a lot of fun. I am thinking about doing some começando. Look, I'm speaking Portuguese. I do speak Portuguese every day. That's why I get mixed up sometimes. I'm talking English and it comes out because my wife is Brazilian. We speak Portuguese every day. We sort of know each other that way. But anyways, I'm thinking about also, I'll be talking about the particle model, but I think I'm going to try to do it on our Universe Hack channel and start talking about that model as well. Because I do talk about it quite a bit on my channel. And hey, I should probably get more into depth in it, even though our book will be coming out. So, all right. Well, we got our. It takes a little time, I know, for people to join in. I actually am getting this down, I believe. But anyways, it's been a lot of news about space-time. I'm going to do a video very soon on space-time. If it's not space-time, what is it then? That's a very good question, because of course the space-time articles are coming out left and right now. It's quite amazing. So anyways, I'm gonna wait a little bit longer so a few more people join. We are going to be announcing I have an announcement for any of you who are going to be on the West Coast in June of next year, June 26th through the 29th, 26, 27, 28, 29. I always have to find, get three numbers, but they're 4 days. From Wednesday through Saturday at the University of Washington in Seattle, just north of Seattle, the city. We will be there from Wednesday until Saturday. We will be broadcasting live, of course, as well. If you're not going to be able to make it there, of course, those live broadcasts get recorded as well. We're getting quite a lot of views. We're getting a lot of more interest in our group when we have those really nice sort of edited on the fly, because that means when we get back, we don't have to edit. They're actually instantly available. So, oh wow, somebody already went away. But anyways, I'm here. So must be Greg. The other person left. They're probably trying to figure out what's going on. But anyways, I'm going to start talking about ether pretty soon here, and we'll see what goes on here. And Greg, I see you are here. Where are you from? What's your area in the world? We'll see. I know there's a little delay and stuff, but we'll find out where he's from. And I'm going to take a look at some stuff here. Since I lost a person, that means, hey, I'm not doing something that's super interesting necessarily for everybody. So I am going to go to a website. I'm going to talk about in generalities anyway. So let me go to a browser here, and just listening in the background, Sydney, Australia. Whoa, wait a minute. Like, what time is it there? Whoa. Oh, is it like early morning there, I think? I do have a really good friend. I got some really good friend there, Dr. James Maxlow. Good friends, but good friends. So let's see what time it is there on the world clocks. Sydney, it's 11 in the morning. So maybe it's your, yeah, there you go. Hey, there's Lisa. Hey, I've been watching your channel a little bit. It's pretty interesting. Hola from the sunny Brazil. Oi, tudo bem, cara? We have MX25A, a Brazilian there. Tudo bem? Tudo jóia? Bem-vindo a meu canal de YouTube. So, great. We got people, one person from Brazil, one from Australia, and got really some of my favorite scientists. Andrea Assis from Campinas. You should take a look. You'll see I have, I think, one interview, but I've also got several videos on his work as well. So really great people. And Australia has some absolutely fantastic scientists, especially in expansion tectonics. It is wonderful to see people from there. But I'm going to talk about ether today. And so let's see here. I'm going to get myself together here. And so great to have everybody. Okay, what is ether? I'll talk about that. But first of all, I want to inform you about our website, which is dbdatabase.naturalphilosophy.org. Go to the topics area. Here you go. I'll go over that, and you'll see all the topics that we have. Our database is the most extensive online database of work. And it has all the electric universe, electrodynamics, expansion tectonics, gravity, new energy, particle physics, philosophy, relativity, special relativity, structure, Tesla, unified theory. We basically try to catalog our almost 13,000 pieces of information into groups. And I'm going to be talking about ether today because that is super popular among people outside the mainstream. It's been around for 400 years. If you go to this page, you're going to see here, I believe I've talked about this before in some of my videos. There we have 448 abstracts on ether. We have 55 books, and we have 94 scientists and a bunch of websites. I know some of this, the display of this, if you're on a regular computer, it looks okay, but I really need to get after this because it's been a while. So many people watch these things now on phones and look at these things on phones. I need to really, and I've been trying to go, it's on my list of 1,000 million things I do in my life. But it is interesting. So if you do want, the reason I want to put that up front, if you do want to browse around and read about people who are etherists, etc. In fact, you can click on 94 people. There's Jeff Yee. And we've cataloged. If we have a picture for them, we'll put a picture in them. If not, we don't. But again, you can see all these etherists there. In fact, one of the best etherists out there I would recommend is Dr. Glenn Borkert. Read the Universal Cycle Theory. I would, for instance, Lisa, who you're not a technical person, I think you would really love that book because it isn't a technical book, but it talks about science in a way that's pretty easy to understand. The infinity part is actually quite interesting, where you have ether at all levels, up and down in the universe. And infinity is really an important part of modern theory. But you can see there's quite a lot of people, broken gifts and stuff. We've been hacked a number of times. We actually had. I will say that we've been hacked from Latin America, including Brazil and other countries. Some of the best computer scientists are out there, but they have. Some of them wrought havoc upon our website, and I've had to restore it numbers of times. But now we have a service who sort of watches over us so that that doesn't happen. But anyways, let's talk about ether, and we will. I'll just start talking about it. It goes back really even further than that. Let me go to, let's start at this one. This is Wikipedia. Ether theories. Darn it, I got something in my throat here. But I think I'm good on the volume and stuff. I got a pretty strong voice, so I apologize, sound bad. But the ether theory, I want you to note one really important thing is you can see in the very first sentence here, in the very part of Wikipedia, it says ether theories, also known as ether theories. The reason we in our organization try to stick with AETHER is simply a way to distinguish that from the gaseous ether, which is I believe it's an element, if I'm not mistaken. I am not super good at the periodic table, but I believe ether is. If somebody can let me know, I think so. But anyways, we do spell it AETHER. And you can see here is known in physics. Purpose, in physics, propose the existence of a media, the ether, and a space-filling substance or field thought to be necessary as a transmission medium for the propagation of electromagnetic or gravitational forces. Okay, let's just get into this right away because this is from Wikipedia, which is the consensus of everybody. We have our own Wikipedia called wiki.naturalphilosophy.org. Same software. I put the same software up. And one of the things we have to do, and I'm trying to get more and more people to help out, is for us to rewrite these things so that we can put in the modern twist on this. And there is actually something here. I found it today when I was looking at it. It was quite shocking. There's actually somebody from our organization on this page, and I talked with him. Unfortunately, the man passed away in 2011, but I was totally shocked to find him listed at the bottom of this page on Wikipedia. Now, I don't know if maybe people aren't paying attention, or because he had a degree in electrical engineering from a university or something like that. Here in Florida, which I live now, but I wasn't here at that time. But anyways, another, if you look at some other explanations, you can see here ether, luminous ether, was the hypothetical substance. So what you have here are a couple things I want to point out. How, again, being a critical thinker, you got to be real careful about every word that you're reading here. The first thing I do want to say that it's a propagation of electromagnetic or gravitational forces. Wrong. It is really it's really meant to explain light, basically, why there's light. Light is a wave. If it's a wave through something. How can you have something in the universe that is a wave through something? But then Einstein comes along and says it's a particle from his photoelectric effect, which he won the I was going to say Oscar for, won the Nobel Prize for. But just looking at this to say it's a propagation of electromagnetic or gravitational forces, it's a little confusing there as to why they're saying that exactly. I think it's because in the beginning people were looking at gravity and they were looking at light, and they weren't sure in either one. And it turns out in the modern world, most etherists almost always start out exclusively with light, and then they work gravitational forces into it. In fact, that's the biggest difference between all the probably 10 to 15 serious etherists around the world. How that gravitational component fits in. So when they say electromagnetic or gravitational forces, I'm not, again, I think the people who write these are not, they don't get ether experts, because there are none in mainstream science. There are people who know the history, and if you call these places up, they go, oh yeah, we don't teach this. We teach a little bit of history, but he's read a little bit about it. He knows more about that. That's what they say, even with relativity, believe it or not. Relativity is not something people major in it anymore. No, it's not majored in. You won't find PhDs in relativity anymore. If you try to call up all the universities, you're lucky to find one person. The last big person in relativity is Kip Thorne from Caltech. And of course, he stuck him in on that LIGO to get his Nobel Prize so he can consecrate himself in the holy book of physicists gone wrong, as I say. But anyways, that's interesting. And then here, of course, they're saying was a hypothetical substance. So basically, this is a different take on it. This is from scienceworld.wolfram.com. Now, if you don't know anything about Wolfram is a place where they try to do be able to ask questions about calculations. It's almost like a knowledge database in a mathematical type format. You can read at wolfram.com, but this is Science World of Wolfram. So they have these people writing this, and this is a totally biased article. And you can see that the result was later on used by Einstein to refute the existence of ether and allowed him to develop special relativity without this artificial constraint. Oh my goodness. Now we're going to have to get into, I've talked about this a lot as well. So I know I'm sort of bopping around here, but I want to just talk about what I think right away so I don't lose this. But this sentence really stood out to me. The result was later on used by Einstein to refute the existence of ether and allowed him to develop special relativity without this artificial constraint. So the whole idea is that when Einstein came around and did special relativity, he said that light and all this stuff, and eventually, of course, it didn't really work out, because it turns out that he had to have general relativity come and rescue it because he had a lot of paradoxical problems. Long story. So this whole sentence is fraught with problems. Einstein to refute the existence of ether. That is really well researched by Dr. Ricardo Carrazzani. If you go to autodynamics.org, he talks about this whole idea of refutation of ether. And the way they did it is Einstein used his equations in special relativity to generate the Lorentz equations. The Lorentz equations were sort of the thing that everybody was using for ether. Basically, Lorentz says you have two frames. I can't get this to see you well. There you go. Maybe like that. See these two frames? This is a frame. It's an XY coordinate. That's all a frame is. So you have two frames, and there's calculations between them, and you can do all the transformations between two frames of reference. Like you're on a train, and I'm standing on the ground, and the train's going by me. So all of this is where it comes from. Just if you don't know, Einstein used it and supposedly generated Lorentz's equations without ether. There's a real big problem. Carrazzani found that has two errors in it, and one error is putting two velocities equal, and the other error is that when you do the calculations, which they never really show clearly, you come up with 2/3 instead of 1/3, and that is also wrong. So the entire idea that Einstein refuted this via these calculations, which I will be honest to goodness that I'm not sure Einstein himself even did, that maybe someone else did, that in fact this is all just a house of cards. And of course, to develop special relativity, which we show wrong in a myriad of ways. I mean, just thousands of ways. Again, Carrazzani, in my opinion, is one of the best. You can look at my father's work as well. You go to youtube.naturalphilosophy.org, and you go there and you will find a video from 2000 and 16, or basically look at our second most viewed video. My father, you know, I don't have my sound effects. Some people are like saying, hey, you don't need the sound effects. I like them, but doesn't matter right today. I just don't have it hooked up on my computer because I've got lots of things. I even have drawing tools today if I want to do some drawing. No, this isn't like Lisa. No, I'm not going to draw a cat or anything like that. I'm talking about just real quick sketches. And yes, I am an artist. People don't go to thehilster.com and people go, no, when you said you were an artist, I mean, you're an artist. So, but I'm not gonna draw those today. But I do have it in case I need to do some diagrams talking about ether or whatever. So this entire sentence down here, the result was later on used by us to refute the existence. Well, it was. Again, I'm not sure Einstein himself did that. I think other people may have done that, but again, I may be wrong. It's not important. And then ether was allowed him to develop special the existence of ether, and allowed him to develop special relativity. The other thing is there was a Michael and Morley experiment, and that's a whole nother can of worms. Basically, Michael and Morley spent time, and I will spend a little time talking about that as well. Again, this whole sentence is developed with this artificial constraint. So basically they're saying that anybody with an ether theory it's an artificial constraint that you need to have ether. And of course, a lot of this again comes from the photon, which was, I believe, if I'm not mistaken, that was Einstein's invention, the photon. And that's also disputable by people today, even people outside them. Inside the mainstream, they don't know what that really means, because light is a particle, light is a wave. So let's go to Wikipedia, back to Wikipedia, and we'll take a look at where what they call luminiferous ether. We linguists just don't like these long words. Luminiferous ether. The reason we call it luminiferous, because it means it's for light. And I think the reason they made that different is because they were talking about ether as a gravity as in ether, which I don't want to get into it, because only if you really are into dissident science. My dad knows a lot about this because that's how he came up with the particle model. That's how he solved in my opinion, one of the best solutions, if not the only real solution to the wave particle duality. I know Jeff E. may argue with that, but I'd love to debate him on that. But regardless, the whole thing, the whole idea that gravity would be an ether, it would have to be a really low frequency wave. My dad was talking about that, and that's how he came across the big breakthrough that he did. So the luminous ether was suggested back in 1718 in optics by Isaac Newton himself. And he says, doth this, not this ethereal medium in passing out of water, glass, crystal, and other compact and dense bodies and empty spaces, grow denser and denser by degrees, and by that means reflect the lights of the light, not in a point, but in a bending them gradually in a curved lines. This is actually talking about what we call dispersion, where you have a triangle of glass, and you hit a beam on it, it will break into a rainbow. You may see these in a lot of displays at science museums. If you do it for a rectangular one, it doesn't. And actually, I actually hacked that answer. I believe, at least in our particle model, my dad and I were looking at that for a while, and I actually came up with the answer to that. And if our model is correct, that's pretty significant. So I did something. But I'm not here to toot a horn, but I'm talking about, he's talking about light, and he's talking about an ether way back in the 1700s, early 1700s, early 18th century. In the 19th century, luminous ether, that's in the 1800s, meaning light-bearing ether, was theorized the medium of the propagation of light. Now that was the big thing and then in the late 1890s, you had the Michelson and Morley experiment. We'll go to that one. I don't know if it stays on the nice display here. It does not, but see if I do this, if it still has the display. Yes, it does. So what this is, I think it was in actually Dayton, Ohio, and I believe, but I may be wrong on that. I seem to remember that. But what this is here is mirrors and light sources. And this is a huge rock. This is a solid rock. I don't know if it's granite. I don't know what kind of rock it is. Not important. And it rotated on a platform. And the idea is that if there's an ether, then the Earth is going through that ether. Let's see if we can take a look at that. I believe if I get off of this, I will be able to see. No, not in this one. Here we go. All right, here is what they call luminous ether. So the idea was ether is sort of like the air or water, and that the sun is going through it, you know, everything's in it, and we're moving in regards to it. And they treated it as a fixed thing in the sense that it's sort of stationary and things move through it. So the idea was is if we're moving through this luminous ether, that we could measure it. And so if light is going as waves through that luminous ether, and we're going, the Earth at some point is going with the ether flow, because it's flowing, then we would see a change in the speed of light, in the sense of you would see a fringe shift. So basically you shove this, you split a beam, it comes back together, and it's one of those things, if there's a different length, you're going to get a fringe shift. You'll see it on the resulting plate at the end. And so they would do this at different times of the year where the Earth was in different positions around the sun. They would then turn this to do the experiment in different directions. That's why they did it. And they were expecting to easily measure an ether and then tell you that, in fact, you would even know the direction of that ether, how that ether is going, how that basically the ether, let me go back to the picture here. This ether, you would know, okay, it's in this direction. We're going with the ether, and now we're going against the ether. But what they found was, in fact, that they couldn't find any difference. And what was really curious is that Einstein basically said that this was proof, well, Einstein said when he was writing his special theory of relativity, and that there was no ether, and that special relativity showed you didn't know ether. Well, he claimed that he didn't know about the results of this experiment. That's really, really, really hard for anybody to believe. Even people in mainstream are really hard to believe that. One of the reasons he says that maybe is because he never cited any references in his famous 1905 paper. If that paper was written today, it would not be accepted, because you have to have references when you write papers. You can't just write it out of the blue without any reference to work, being like standing on the shoulders of other people. So this is the big controversy that came up. It then gave root to Einstein claiming that you don't need ether, that then a light was actually a particle, even though it looked like a wave. It's a wave, it's a particle, and you got into that whole problem. And so you had ether trying to be detected in the 1800s, in the 19th century, that is. By the early 20th century, Einstein came along and said no more. And then when you go to places like Science World, these guys write, you know, Michelson Morley, right here it was. In 1887, a crucial experiment was performed by Michelson and Morley and Edward Morley in an attempt to detect the existence of ether. Of course, he spells it funky. Not good. The experiment named the Michelson-Morley, the Michelson, I believe, I'm sorry, the Michelson-Morley experiment, sorry, and out of its authors shocked the scientific world by yielding results which implied the non-existence of ether. It did shock people. This result was later on used by blah, 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 as we already had talked way too much about. So what does this really mean? Well, that means that ether was pretty much thrown aside, and then we get, what's really interesting, let's go back here, and I told you that was, detecting ether, it talks about it here. The Earth goes through and it even tells you the speeds, and it gives a little bit more detail of a depiction of the concept of the ether wind, which of course this place picked up that exact same thing from Wikipedia. And they explained it a little bit more detail. It's not really that important. Here was one of the first experiments they did. It wasn't on that big platform because they were worried about it. The reason they changed from this type of apparatus to the big stone later on is because they wanted it to be much more solid. People are saying, well, maybe you've got interference that that people are feeling. So they're looking for that fringe shift. Like I said, couldn't find it. They're talking about it very carefully. This is sort of a bad. I've got it so that it displays better because I've got that little button on above on the browser, so that's why you can't say it. There's a fringe produced by using white light, so they would try to find a change in that. The most famous failed experiment, they didn't find something. That's what they wanted to find. It changed everything. It says the experiments in the relative motion of the Earth and ether have been completed, and the result decidedly negative. The expected deviation of the interference fringes from zero should have been 0.4 of the fringe, the maximum displacement of 0.02, and the average of less than 0.01 was found, so it's not in the right place, blah, 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 blah. So that's what they found. Anyways, the light path analysis and consequences, they talk about it. There's some fancy little equations. They're not that hard, actually. These are the Lorentz equations. Some parts of the equations you see in special relativity. You see this, what's called beta, square root of 1 minus v squared over c squared. Of course, if c squared goes, v squared goes to c, that goes to 0. The bottom of this equation goes to 0, and it blows up. And that's why Einstein says, you can't go faster than the speed of light because my equation blows up. Observing co-moving interference, okay. And they talk about a little bit more. There's the Lorentz I talked about. I'm not going to go through that. Incorrect. Let's see. Then there's the emission theory, the ballistic theory, also is consistent with the exalted experiments not requiring ether. That is sort of a ballistic theory. It's like bullets. That is very similar to our particle model, but it's got the big difference of the waves of particles, which my dad sort of hacked. And then they've also claimed, some people have claimed to redo it and had different results. Some recent experiments and optical tests. They've tried to show it again and again, and that's why you hear all the time. Wait, is this the one? Where is it? Where's Sid? I'm looking for Sid Deutsch. Hold on. Sid Deutsch. Hold on. Not here. Is it the bottom here? Okay. Let's see. There is some place on this. Oh, it's because I'm in the Michael Morris, and what am I doing? I'm in the wrong place, folks. Everybody's saying, like, what's going on? All right. I'm going to get you to questions right now. I'm going to go to the questions. But anyways, it talks about the mechanical gravitational ether. That's in the 16th through the late 19th century. Again, that's a different sort of thing, a beast. Conjectures and proposals. They talk about different people who have been talking about ether. Albert Einstein even said the velocity of waves is proportional to the square root of the last particle. So Einstein even talked about it, other people. And if you go down here, you will find our friend Sid Deutsch. Don't believe me? Here he is in the database right there. I actually talked with him several times when he was still alive. He died in 2011. He'd actually be almost 100 years old. But he was a member of our group, and he's there. Now, I don't know. I haven't checked on the editing of this to find out why he's there, but he talks about ether. He says a professor of electrical engineering, bioengineering, conjectures that a spherical spinning ether particle must exist in order to carry electromagnetic waves. So, and then derives its diameter from the mass using the density of dark matter. Of course, we know dark matter doesn't exist because it's not needed. It's because we treat a galaxy as a point mass. And it isn't. It's got a bizarre and very, very easily seen gravitational. If you have more gravity, if you go by Jupiter, there's more gravitational field there. So the arms of the galaxy have more. I've talked about this so many times. But anyways, very interesting. Sid Deutsch, one of our guys, on the Wikipedia page, and they haven't removed him. Let me go to the questions here. And I apologize, folks. Oh, John Otter, great to see you. Let's see here. Ether is a medical term too. Yep. All right. The study today of ether and ether's thesis that forever increases. Let me change this so I don't have my head off here, right here. So I'm looking at another computer here. Let's see. I love the artwork you showed in your movie. I'm learning different things right now. I'm trying to step outside my comfort zone. That's right, about painting. That's great. Yeah, I did too. I learned that in Brazil, actually. Eu estudei arte lá no Parque Lage, no Rio de Janeiro. I don't know if our Brazilian guy's here, but I just see if he's there. John Otter, is there not a modern experiment in Japan that does something similar? I'm not sure. There could be. It's not just a matter of standing on shoulders, but absolutely necessary for syllogistic deduction. Yeah, it can be, unless you're coming up with something wholly new. And then, well, most of the time, well, it's always based on something. So, Proto-X, tudo bem, Proto-X? Espero que você ainda está aqui. Tudo bem, cara? Let's see. All right, good. Glad to see you guys here. Let's see. I was wondering what makes them think they already know the direction of ether and traveling, and how much shift. It's very, very good question, Greg Stewart. I'm sorry, I'm a little behind on the questions. Great question. Let's get to the entraining. That's I just gave it away. I gave you the answer. Let's go to the Wikipedia. I believe this is Wikipedia. Let's go here. Well, I'll go over here. Anyways, oh, this is Wikipedia. Luminiferous ether. So the question is, says, how do you know the direction? Well, the truth is, we don't know. If it's all conjecture right now, of course. All of our theories are particle model, ether models, and the lattice models. Those are really the three main models that are competing today. We're in a model revolution right now. But this whole thing is, you can see ether. They were looking at ether as being not a fixed thing, but sort of not moving, sort of like water in the ocean. That's not good either, because water in the ocean moves. But basically, if you look at this diagram here, I think I've got my mouse. This idea here is that there's sort of a direction to it, that there is a flow. It's not going to be, because even if, well, the idea is simple. The idea is that they thought that it was sort of stayed together. It was like a soupy kind of thing. And that, of course, for those of you who do not know about how ether works, and that was one of the reasons I decided to get this working, and I will try this. And no, this is not going to be David doing a portrait live, but I will draw today. I've got my pen here on a tablet, and I'm going to draw. This is what ether is going to do. You're going to have lots and lots and lots of basically particles everywhere. And the wave is, while this guy will come and hit this one, then this guy will come and hit this one, and this guy will come and hit this one. This will go off a little bit this way. But the idea is, it's like sound waves. Just like I'm speaking now, there's air around it. That air goes to my nice microphone right here. And that microphone picks up those air waves. And when I talk, it goes in all directions. This is one of the problems with ether and lasers, is because I can't just talk. You can sort of keep things more concentrated, but lasers are a real problem for ether theories. But anyways, ether theories are like, oh, this is like, you know, an ether particle. This is an ether particle. This is an ether particle. And we have, oh, I can do like, you know, different things. So you get the waves are transmitted by those things going back and forth, hitting each other, just like in sound waves. That's what ether is all about. So for those of you who don't know. And because those are particles and those are like sitting out there in the universe, then the idea is these ether particles stay there. And then for these experiments like Michael and Morley, they expected that there would be a flow that exactly like this diagram right here. Exactly like this oops, I'm doing this wrong because I'm putting my mouse in the wrong place. There we go. Got to make sure I do this right. But this flow here, you're going to measure directions. And they thought it was like that. Now, the good part of the question is there's something called in today's etherists, the new ether theories out there, they can have entrained ether. And this entrained ether is an expression they use to explain why Michelson and Morley, for instance, didn't find any result. So I'm going to go back to my drawing here. I can get a new page here. I'm going to talk about entrained ether. So I am going to draw a sun here. Well, a sun. Maybe it's a planet then. Okay. Put some water on it. There you go. Put some land on it. Oh, make it to the... I'll make it like Brazil's there. Europe. Put like... Oh, there's Australia for you. And there you go. So you got this, and there's the Earth in all its glory, which is expanding, by the way, if you don't believe me. Watch my stuff on expansion tectonics. Too much evidence for that, we know that. Okay, so we're going to look at entrained ether. So what I'm going to do is I'm going to draw the ether here, which are going to be like this. And what you have, entrained ether, means there's a lot more here around the actual mass. And so the closer, bigger the mass, you're going to have entrained ether. So there's less ether out here, and then much more in here. And that in actuality, it sort of follows the mass. So if you have Michelson and Morley here measuring, oh wow, what happened there? Oh wow, I don't know what I'm doing there. But if you have, what? I don't know how to use this tablet, I guess. What's going on? I can't, oh, I think it's editing stuff I'm doing here. But anyways, let's put Michelson and Morley right here then. Oh, I can't do it. See, it's the first time I've used this whole thing. I think my daughter has it or whatever. But that's entrained ether. So this here, let me do the yellow here. This part around here is sort of entrained, meaning it's following the Earth. And it follows the Earth around the sun. So if you go around the sun, okay, so what happens is when Michelson and Morley are standing there and they're trying to do their experiment, like right here, it's Michelson and Morley, and they're doing their experiment, they're going to go say, no change. What's that? That's a moeda. A moeda. It's a coin. No change. Get it? Ha! But anyways, no change. So no change in direction. So the idea is in some of the modern etherists that they actually they talk about entrained ether, and they talk about the different ways that ether could behave. This could be the cause for gravity. This could be the reason that Michelson and Morley had a negative that there is ether and white light is an ether. So basically what they're saying is that no matter where they go, the local ether isn't changing. Doesn't matter what time of year, where you are in your orbit, it just doesn't matter. And as we say, I don't know what colors I have here. Ether, A-E. So that's a good question. The whole idea of direction, I'm sorry, I got your name there. Sorry. John. That was a really good question. I believe it's John. No, drifting through vertical may have a lesser drift than the photons. Okay. All right. Yeah, I think that was Greg. I'm sorry, I think that was Greg. Let me finish my... These will become masterpieces. I'll even sign it in my typical... Then I put the year. There we go. Ha ha! Instant art. Actually, I used to make like cartoons and stuff. It's pretty cool. Anyways, so that's the idea. In trained ether, there's lots of different ways. There's ethers that actually flow into... let's see. Do another one here. Let's do it in red. There's ethers that say they flow into it. So inflow. And they actually have some ether then that comes back out. These are the ether theories of today. These are the people that come into our CMPS conferences and they give talks on it and they talk about it, and the etherists have different ideas of how that all works. So it's pretty cool. Alrighty, let's see here. John Otter, it's not a matter of standing. Okay, you did set that. Ether's traveling how much? The drift, okay, we talked about that. Proto X to the bang, and retracted, message retracted. It may be drifting vertical and may have a lesser effect on photons. Okay, that's what I sort of talked about. Greg Stewart, it cannot be ruled out totally yet. Yeah, right now there are three competing ideas. Which one's the best? I'm not sure. Each one has merits. I will say that our particle model describes more things than any other model out there today, but you know, I don't know. It doesn't have the problems of ether. So I think in coverage, the particle model has more coverage, but the ethers are working like crazy on all this. ProtoX, I hope you are doing well. You too, Greg. Okay. Hi, Lisa. Will regular lessons. Nice history of logic and those math foundations. Hey, I think she's bringing like people here. All right. Lisa, Dave, I've been experimenting doing different kinds of painting that I normally end up feeling amazed at all the science actually involved in painting. Yeah, color mixtures. Oh, color, Lisa. Color, color, color. I definitely have to talk about the particle model because my dad and I have come up with some amazing explanations of color. And actually, there's another guy, Luiz Sarobon. He is from Niterói. Hey, brasileiros, você conhece aquele universidade no outro lado da Bahia, do Rio de Janeiro? O Fuji, cara, eu não lembro. Mas tem uma universidade, tem um cara lá que ele tinha um modelo de cores, modelo mecânico de cores, que é uma coisa, foi super fascinante. Mas, anyways, I'm talking about to the Brazilians that there's a Brazilian guy from Niterói. Niterói is like the New Jersey to New York. You have the best views of Rio de Janeiro in a sunset from across the bay, across Guanabara Bay in Niterói. And there's a university there, and there's a guy there, Luiz Sarobon. He's an engineer, and he gave several talks on color, the mechanical model of color using particles. And it turns out that my dad and I actually have taken that, not his, but we've taken that idea really far. And I can tell you why this shirt has this color. Bernie Sanders' hair is white, why this one's black. Give you an explanation at the molecular level at what is light and how that works. the whole thing, transparency, dispersion, that the entire thing. So our model can describe all those things. So color is super interesting, and it will make you think of the world. So maybe I just do need to do about color in the particle model. I think you guys would like the particle model because you don't need math. Let's see. It's talking more about the painting. Question: could ether and plasma be similar? Also, can you tell us one thing which you disagree in terms of the electric universe? Well, I hope you're still here. Yeah, I hope so. Absolutely great questions. And I've actually mentioned some of these before. But your first question is, ether and plasma, could they be similar? No. Plasma gives off light. If ether was the is the substance in which light goes through, waves through, then you have a problem, because you really have two things going on that can't be described necessarily by one thing being ether itself. Plasma is a harder problem, and I think that's one of the things. I'm not sure what ether is taught to do with plasma. They say, I think they say, I don't know what they say. My father and I's model has a different answer to that, and I think it's a clear answer, but the ether and plasma, I'm not sure, unless I have not read of an etherist who has answered that question. But in my opinion, plasma is a different beast from ether. But somebody may have a model that would disagree with that. Plasma, in my opinion, has a lot to do with the heat content, the motion of molecules of subatomic particles, and the light it gets off, that kind of stuff. It's something my dad and I have talked about. I don't even remember in our model too much about it, but plasma is an enigma in general. But unfortunately, it's a great question, but in my opinion, I think they are different things. Or plasma is the result of something that it's not. Plasma is the ether, and ether is plasma, is just another form of ether. I couldn't say that for sure, but in my opinion, that's something. Also, can you tell me which you disagree in terms of the electric universe? Very good question. First of all, I do want to say that there's a lot of things that are electric in the universe. The disagreement I have with it is that it rests all upon the electric field, and it rests upon charge, positive and negative. And they don't explain what that is. Basically, I guess they're going to say the assumption is electric field and charges are assumptions. They are the postulates. They're the basis on which they build everything. The only disagreement the thing that has always kept me from the electric universe, in the sense of, I would say the universe is totally electric, which they say, is the fact that I don't like the idea of non-physical things in a model. An electric field, again, I'm not sure they describe anything. It could turn out that they turn into etherists, and they'll start subscribing to Yonel Deneu's underwater experiments, where you see the flows that act just like electric fields or magnetic fields. It could be an evolution that the electric universe will get there, because they've already evolved 10 years ago. They were never talking about Einstein being wrong. They were never talking about black holes being wrong. And now they talk about those things. They never talked about mechanism for gravity. They say it's electrical. In our model, my father and I's model, we describe exactly physically what electric fields are. And in fact, our model is infinitely down and infinitely up, so we don't have a basis. We just have the next level down. But we would say the universe is just a bunch of moving mass that hits each other, and you can build the entire universe from that, including the electric universe. So what I would say is that the electric universe has a lot of great observations about the electrical part of the universe. But I've also talked various times, not at length, but enough with, I know personally, Walt Thornhill, I know personally Dave, what's his name? Gosh, David, I'm so sorry. I admire you guys. You guys are putting together all these critical things. David Thornhill. David Thornhill, I think. Yeah, I think that's it. But anyways, I've talked with them, and we had a sort of clash moment where he said everything's electrical, and I said, well, you know, the difference between electric universe and the CMPS at the MPA at the time, but the Natural Philosophy Society that we have, is that the electric universe is a subset of our organization. And Walt Thornhill looked at me and vehemently disagreed with me and said that, in fact, everything's a subset of electric universe. The whole universe is electric, and everything's a subset of that. Well, again, the only reason I disagree with that is because you don't tell me what an electric field is physically. You don't tell me what charge, why positive and negative attract. You use that everywhere. You don't tell me why it's sort of magic. I don't like that myself personally. And in my model, in my father's model, we actually have physicality to all those. There's no charge in the universe. You know, there's not something that you put over here and there's a plus sign on this and there's a negative sign on this, and because of that they attract or they repel. It's a convention we use. The only reason something moves is there's a force. So if you have a magnet and you push it near another magnet, it's force. There are really things that are happening. And in our model, it's simple. Electric magnetic fields are flowing particles, just like the flowing particles or the flowing water in Yonel-Deneu's experiment. When they go together, things will attract. If they go against each other, they will, if the flows go together, they will attract. If the flows fight each other, they will repulse. And so the things, so that's what's it. So the biggest disagreement I have is, number one, electric universe is actually a subset of the way the universe works, in my opinion, which is just basically moving mass, and in charge and fields are moving mass. And the other thing is they don't tell you what those things are. So those are my big disagreements. Okay, I'm still here behind the chat though. Okay. Please, I don't know, let's see, I know you don't agree with relativity, so do you believe the existence of black holes? What are they if you believe in their existence? Thank you. Okay, very good question. Muito obrigado, cara. Uma boa pergunta. Você está perguntando, você não concorda com a relatividade, mas você acredita na existência de buracos negros, e se você acredita, se você acreditar, o que são? Muito obrigado. All right. That's what I'm translating as question. Great question, actually, super question. So yes, I don't agree with relativity, and relativity only has to do with black holes because that's the origin of black holes in the sense of general relativity. That's where people first thought of these very immense, well, actually what they thought of were mathematical things which are infinite points with infinite mass, and that nothing could escape from it, including light. Of course, if you don't have a model for gravity, if you don't have a physical model for light, how do you know? Okay, the answer directly to the question, I don't believe in black holes. I believe in very dense objects. Okay, let's explain what that means. An atom. Okay, let's take a look at an atom. It's basically got two components, an atom. It's got its nucleus, which is bigger, and it's got things that orbit it. In the mainstream, we have neutrons and protons, and we have electrons. The more modern mainstream is now starting to say only neutrons and electrons. And our particle model says neutrons and the G1 particle. More than one. So if you have hydrogen, you have more than one. You actually have what this can hold. So regardless, you have a nucleus and you have an electron or a thing going around the nucleon, we call them. So just call them nucleons. Don't call them anything. When the atom blows apart, which happens all over the universe, suns blow atoms apart all the time, you have free-flowing nucleons. If these nucleons get all smashed together, you have a very dense object. In fact, we have some really great scientists. Unfortunately, some of them have already passed. Actually, one of them has, Bob Heaston. And he was doing calculations. Look up Bob Heaston. Heaston is Heaston, A-S-I-T-O-N. And if you go and look him up, that's his sobrenome, you will find he has the maximum force of gravity. And what happens is you don't have an infinite point with infinite mass. Even Stephen Hawking got away from that because they were finding what they call black holes, where things coming out, and it wasn't supposed to be coming out. So the answer to black holes is there are no black holes, but there are extremely dense objects which we can see in the middle of the galaxy. If you watch my movie, I show you Sagittarius B, which is a movie we made for over 15 years of the center of the universe. Oh! I can't believe I used that stupid phrase. There's no such thing, the center of the universe. There's an origin you can put in an infinite universe, but there ain't no center of it. Let's see if I can look that up. Sagittarius B. Sagittarius B or A animation. Already people looking that up. So let me get rid of some of these so we can get it. Here we go. I will show you that. I'll make sure I get this going before I get it up for you. I will get rid of the music because usually they have terrible music with these things, or they don't have music. So let's take a look at this right here. Now, if you look at this, take a look at the X in the middle. This is I first saw this with Dr. Edward Dowdy, a NASA scientist who worked in observing the universe. Okay, let's do it again. There it is. Now, if you look at that X, you're going to see one of these stars go whip right there. See it? Watch it again. You'll see it come up closer. There it is again. Watch that one star whipping around that X there. You'll see it come in. Here it comes. Whoa, there we go. Now, what does that mean? Right where that X is, right here, there's an extremely dense object. Is it a black hole? Well, I have a real problem with a black hole because why isn't it sucking everything in? Why isn't it sucking this? Should be. So the concept of a black hole comes from special and general relativity, mostly general relativity. And that concept with the infinite point and infinite mass, in the beginning when we were just fascinated that we were super brains and that all of our theories were right, we discussed all this stuff, and because we were so smart that our theories were going to tell everybody how the universe worked, we were going to talk about black holes before we found them. Well, we started finding very dense objects, but this doesn't fit a black hole. This fits an extremely dense object. In my opinion, in our model's opinion, it's basically non-atomic. It's basically subatomic in nature, that you have mostly nucleons. And so that's what I would say. But of course, they can see the stars. They can see these things moving around. So the answer is no. According to general relativity and mainstream, there are no black holes, but there are very dense objects, and those dense objects exist, and we can see gravitational evidence. We do not see space-time bending it. These big black holes or big dense objects are not bending space-time because there's no such thing as space-time. You can have an ether, you can have particle models, you can have particles. It's full of stuff and space, not solid. Or you have a lattice, and those things are there, but that doesn't bend light. Mass bends light. And if you have a very dense object, guess what you're going to have around the dense object? You're going to have mass. It's not going to be like this is the really massive thing in the middle of our galaxy, and right above the surface, there's nothing. That's really hard to believe. Really, really, really hard to believe that there's nothing there. And so that when you have a density this big, and that's a gravitational density, you're going to have mass around it, even if you can't see it. We have stuff around our atmosphere. We don't necessarily see it. We can see it when there's light going through it, but regardless. So there is lensing of light, but it's because there's something there. It's not space-time. No black holes, extremely dense objects. Yes, this is proof that that is there. We can see it happening. So this is proof that there's an extremely dense, in fact, can't remember, it's like 10 million times the mass of our sun or something. They've calculated it. So I hope that answers that question for you. Tudo bem? Gostou da resposta? Provavelmente não, cara? Não gostou, não. All right. Natural philosophy can cover most all theory models, whereas EU is specifically a model. Give that guy if I had t-shirts, I'd send you one. Let me get stopping this because that's like, whoa, stop that, get rid of that. It's distracting me. Absolutely, the EU is a model of the universe. Absolutely. And in my opinion, it's not a complete model, but it's a model. And hats off to everybody in the EU. I support you 100,000%. Keep going using that model. Go as far as you can. Why? Because you're critically thinking, because you are challenging mainstream, and you are showing different things that mainstream shows wrong. You're showing better models for it. Better models always get my support. Alrighty. Let's see here. Move in here. Sorry. I hate trackpads. Okay. Let's see here. Although they are, let's see. Although they have a huge following and great evidence and ideas. Well, they have evidence that they say supports their theory, but we have different explanations for the same theory evidence. Let me give you an example. Something I don't agree with. This is something, Lisa, I don't agree with. I don't believe the Grand Canyon is catastrophic in nature. I don't believe it is. From what I can see in the geologists that I talk to who are expansionists, comes from Earth expanding. The Earth's expanding constantly. And canyons are going to be part of that. Also, as well, there's a canyon on Mars. They say it's electrical. So you got to be careful. The evidence that they show is one interpretation, and there are other models and other ideas like expansion tectonics that explain it's the same thing. So, yeah. That really explains it for me. Thank you so much. Mind you, I'm a few minutes behind. Yeah, absolutely. I'm sorry. We are a minute behind, I think, in the delay of seeing this. Well, it sounds like there's quite a bit of agreement, but you also explained it well and you have logical. Okay. I'm gathering that you are very much a physical model kind, not a theoretical in a fair assessment. Absolutely. And I think a lot of people in our group are a lot of them are that way. We are tired of non-physical. Look, physics. The universe is physical. Now, if you want to call something metaphysical, then no, I'm not a metaphysical person. I am not a religious person. I do not shun anybody. I do not get mad at anybody. One of my best friends, if not my best friend in the area of dissident science, Greg Volk, he is a creationist, but I respect him immensely. We are great friends. I am not religious. He is very much so, but we respect each other. I respect him. Can he be right? Yeah, all that stuff could be right. But regardless, what we talk about really is physics. And this idea, I think that's the big rebellion. I mean, you put your finger on it, your thumb on it, basically. You know, here it is, your thumb on the problem. And that is, I've got to have something real. I can no longer accept, oh, mass increases as you get closer to the speed of light. Why? Just the way it is. Oh, space-time bends something. What is it? Is it a foam? Is it a fabric? Is it particles? What is it? Well, we don't know what it is, but it's there, and we know because we have evidence for it. But the evidence you say isn't evidence because when the NASA guys goes out and tries to find a bending, it's not. Why do you cherry pick it? Cherry picking is a big problem in the dissident world, and it's a big problem in mainstream. We have people who will get married to the idea. It's just like the electric universe. They are evolving, which is good. Like I said, they are now saying things. We used to laugh at the idea that Einstein's wrong. Now they actually support that. But the idea that people will cherry pick, that is, I'm an etherist, but I won't tell you how lasers work. And I ask you, how do lasers work? And they won't tell me. And they say, well, I haven't figured that out yet. And I'm not satisfied with that. I've been around etherists longer than we've had our particle model. The reason I go to the particle model is because it's got an answer. It tells you what it is. Isn't that really what we really want to know? What is light? Just tell me what it is. Don't tell me it's a field. Don't tell me the mathematics. I got a degree in advanced calculus. I got a bachelor's of science and I love math. Math's a wonderful thing, even though our real number system needs to be changed. It's not that, it's got problems with negative square root of -1, which gives you imaginary particles, which is terrible. So yeah, I've always said that there are going to be people who are more touchy-feely, they like energy and all that stuff, and they're more metaphysical. And that's okay, but in physics, I don't think people who are like science want to know, what is it? Tell me what it is. And so, yeah, I'm that kind of person. Okay, thank you. Muito obrigado. All right, he got my answer. Greg Stewart. I wonder if the observation of that star whipping around something near Sagittarius A was confirmed by more than one observatory. Oh yeah, it's probably the most studied area of the galaxy. It is absolutely studied like crazy now. It's so, yeah. So it is. I know that because I talked with Dr. Dowdy, Edward Dowdy. Love the guy in my film. He's been on Sky Scholar, right? He was just on Sky Scholar. He has the extinction shift theory. See, we're going to have that on the website, sciencewoke.org. We're working on the theories right now. We're trying to get those in there. You guys want to help me? Always need help. You know, if you want to learn about distant science, come and help me with the website. What I need is a guy like Eike. You know, Eike no Brasil, bilionário, me dá dinheiro para eu fazer isso, o tempo integral, eu não tenho que ficar trabalhando em outra coisa, posso fazer isso direto. Well, I just asked the Brazilians, hey, you got your billionaire over there, have him fund this so I can do this, you know, I can get this website would be done. And I'd have a TV, I'd have all kinds of stuff. Let's see. Lisa, right, I agree about the Grand Canyon and the Earth expanding. I guess that Wall Thornhill uh, talk to text, I guess he allows for that now. Could be. I told you they're evolving, and I respect Thornhill quite a bit. Oh, that's Wall Thornhill. I said David Thornhill, was I? Wall Thornhill. David Talbot. I got it, David Talbot. If you ever watch this, sorry, David, I got you wrong, but again, congratulations. And I will say this: the one person was talking about how well organized, and they have a lot of followers. They started 10 years ago. And people who started 10 years ago and constantly put out new videos, what happens in YouTube, it's an accumulative thing. So what happens is you put out more videos, more people find you, and it goes like this. It's just like me. I started a year ago. I've only got 2,500, almost to 2,600 followers, and it's going like this. What happens is you get more views, you have more videos, and they've got hundreds of videos. I don't know if they got 1,000. And they get more views, and those more views then make YouTube put them up higher, and they get more views, and they get more subscribers. And so that's the way it works. So they've been around since 2008. I've been around since 2017. Yeah, 2017. They've been around almost 10 more years than me. So who knows that this channel could have it, and we're doing more videos, we're doing better productions at our stuff. So I'm taking a cue for them. They are organized. 2 thumbs up, absolutely. Jealous as heck, that's for sure. So I think there's cherry picking in religion, in addition to ones you mentioned. There's cherry picking everywhere. Cherry picking in politics, you know, the Democrat. Oh man, don't even get me started on that. And I won't talk about that because I'm not here to hurt anybody. Yes, I'm a progressive because I believe the human race should be nice to each other, and we're only as good as the worst treated person on this planet. It's really sad to me that if you're born, it depends just where you're born, whether you're going to have a decent life or not. I mean, we're supposed to be advanced civilization, for goodness sakes. Everybody, you know, when you ever see like Star Trek or you know, you go, it's like you don't see homelessness and people, well, unless you're in those destructive ones or those Armageddon ones. But you know, you go to Vulcan, you're not going to see people Vulcan begging, because they're going to say, no, we take care of everybody, you know. So, but this was one of the things about being science woke. And that's why I registered that right away. Got sciencewoke.com too. So, what help do you need? Oh, I need people to help me with a website. I have numerous websites that can use help. We have a Wikipedia where we need to write up stuff in our Wikipedia. We have problems with it. I put our database into it. That's one thing. So if you like Wikipedia and you like starting to write stuff in there, you can. The other one is Science Woke. Science Woke, I have mainstream problems that I need to catalog. I have already a template for it, so you don't need to, you have to just fill in the stuff and write stuff. Just writing it. We have a online base camp. I will show you that. Let me see here. It's on our website. So I'll go to that, go home, and I will show you. We have a way we organize. So if any of you want to help, we've got this thing that I've used before, and I'm going to show you right now. It's coming up on the screen. If you go to our website, naturalphilosophy.org, and at the very top, we are using a new tool that I've used in software engineering for projects. It allows, literally, we have people all around the world working on our websites, working on our conference coming up. We have people working on our forums, all those kinds of things, meetings, setting up our Saturday morning videos. Tomorrow morning there's a video conference that they have, but you can join in and everybody can talk and that kind of stuff. Well, come on, where are you? It's going slow. There we go. I'll just go to that one. Oh, there we go. Alrighty. So basically, here is what it is. It's Basecamp. I even made a little video introduction of it. and you can go and sign up for Basecamp. So the first thing you want to do is go in to headquarters, hq.naturalphilosophy.org. I'm so organized with my web stuff. And you go there and you say, or just send me just follow this page. And how do you get to that page? You just go up here on the home page and click up the very top right there. Join the CMPS Basecamp help. And you can just go in there and see what you want to help with, sign you up and follow, and we have all kinds of stuff. I can even show you. Why don't I show you how we're organized? hq.naturalphilosophy.org. It's already there. I hit this, and it goes to our headquarters. And here we have all the people that we have working around the world. That's all these people. You have message area, you have to-dos here, that kind of stuff. And I've broken it down to groups. We have teams. We have adopt a scientist for those people who need help. They're scientists, maybe they're older, we need to adopt them. That's one we just haven't started yet. We have the Chappelle University, we have the websites and database. This is the directors. I won't show you that because that's a private area for we directors. Featured scientists. We're going to be working on that. These groups are mostly inactive. I just made them. Members outreach, which we need to do as well. We need to just contact members and say, hey, how you doing? Can we help you? You got to come to our conferences. We have video conference Saturdays, which we use quite a bit for generating our Wikipedia. And so underneath like websites and databases, we talk about all the websites, which is one of the things we need. And we have projects. We have the university website, which we just started. We have the past conference, which we are the post conference from this year, where we're gonna have to send out stuff. We have the conference coming up where I've just got ready. We're going to be ready to launch it. We even have our poster ready and our guest speaker, great guy. Look him up, Gerald Pollack, the 4th state of water. Can you believe it? Water has 4 states, not 3. He was drummed out for a while, but now they're starting to come around. We have our forum project. They're working on the forum. These are just some of the 2 of our people we're trying to feature as. But here's the big one, Science Woke. And here we have documents to do. So here's one of the things we're doing right now, list theories for the Science Woke website. And what I do is we make all these things and then you receive emails. You come in, you become part of our group, and then I make a to-do list and a list and the to-dos. I assign it to you. It'll email you. You can even answer an email and it'll put it in here so we're all organized. So this is where we go. We did a Grand Prix, major flaws in major flaw areas. I need people to help me with the major flaws, get them in there. I make the graphics. We need to type up that stuff. Hey, I mean, it's all built on the fly. It's all done over WordPress. All of these things in the Science Woke site. If you go to the Science Woke site, you won't see this. Oh, you'll see this. There you go. You got to log in, and if you have a login, which I do, Hilster, sometimes it takes 2 times to get in there, then you can come in. I'll give you a login for it, and you will be in here, and you can go in here, and I'll show you some of the things here. Let's go in here. This is the website itself. It's sort of scrunched down. Revolutions here, and here's why. That's a really great article. This is my best article in 10 years. Mainstream science sees no crisis. I'm writing that one as well. Failing at science and education. So this is where the science woke people will go to become woke. Let's make it a little bit wider. There we go. You can see there are problems in science. You can click on that, and I have those here. Black holes, there's problems. Plate tectonics. All this stuff. So when we go to these, we need to have information. We have to have these filled out. I have some things here. See, we have a little table of stuff that when you edit it, then I have all these things already from the database. But we need to write about this. We need to write blogs about the problems with black holes. We have to have one article about Stephen Crothers. Look him up, read about him. You can just be a reporter. I don't need you to understand it necessarily, but you can report what they say. Stephen Crothers should be on black holes. He tears them apart left and right. We should have his videos listed, those kinds of things. So these are the kinds of things, so that when a person comes to the Science Woke, they're going to say, oh, you come here and you go, oh, I want to become Science Woke. So I click on this, and the Science Woke will say, become Science Woke. It talks about it, blah, blah, blah. And then it says, here are the problems, and we'll be able to click on that. Oh, there's a problem with the Big Bang? I never heard it. I thought it was right. You click on it, and you're going to get all the stuff that's information about that. So if you go to the problems in science, and you click on the Big Bang, then you're going to go and find out, oh, what's really wrong with the Big Bang? The Big Bang has some problems. It's bad. Yeah, it doesn't. It's very fatal. We need. I'm making this. I need people to help with this. So that's sort of the idea with this whole thing. So I need just help. You don't even need to know exactly what to do. I will point you in the right direction. Just start putting it together. I will go in and re-edit it if we need to, but I just need people to fill stuff in. Right now I'm getting people to fill in stuff for the new theories. Here are some of them. There's the particle model, there's the universal cycle theory, there's autodynamics, there's Jeff Yee, the energy wave particle, the infinite universe theory, there's an ether theory, great ether theory. Here's another ether theory. You see it's listed as ether. It's ether and Newtonian, fractal cosmology, Newtonian, ether and Newtonian, you know, that kind of stuff. So all of these things, and then when we click on them, we got to have, and the blog has to have information about these things. So we have scientists. Who are the great scientists and who are the critical thinkers out there? Here are some. I've already been through them. Great, seriously great scientists. This guy's just fun because he's a retired Supreme Court justice who has his own ether theory. Ha ha! I call it the Vancouver ether theory. I gave him that name. Ron Hatch, GPS scientist, with 30 patents, says GPS shows the flaws in relativity. So we need to have this. So what happens when a person goes here? They're going to go, oh, I can start here. Here, oh, problems in science. I can click on that. Oh, scientists, tell me some about. Oh, tell me about some new theories. Once they do that, they can go to the members' website, the forums, the Wikipedia, the online university, and take courses on dissident science. Who are the scientists? You know, they can go through and take a course and then write a report and all that stuff. So all of these things can be done anywhere in the world. They're all organized through our headquarters, and we have things going on all the time. If you want to see some of the activities we have going on, you just go to activity and you'll see what we have been doing. David D. Hilster is talking about contacting those theories in the Grand Prix for the CMPS. We had 15 theories, maybe, that were in the Grand Prix of Theories, and Bruce Nappy from MIT. Oh, I thought you guys didn't have people who were educated. Yeah, sorta. We got them. And we're talking about the theories, the list of theories, and I'm having him go to the website and do it. I said, please help me. Put those in there. And I have really great things for the theories. Let me see here. If I go back to Science Woke, pretty cool. You guys are getting, you know, yeah, new theories. Look at all the things we have. Let's go to mine because I can fill mine out. My dad's. Oh, it's not here. If you edit the theory, I don't have them displayed yet. I'll show you. So here's what you would do. Greg, if you were asking, who was asking? I want to get back to your questions here. What help do you need? Greg. So if you come in here and you're putting stuff in, we have the theory type, premise, teaser, authors, that's easy. Matter is made up, and here I have matter is made up in our part of the, it goes all the way up and down. There's G1, G2, G3, all the way down. And nucleons. Infinity, does it use it? Yes. Ultimate particle? No, we do not have an ultimate particle. It turtles all the way down and all the way up. Light are waves of G1 particles. Gravity are random G1 particles. Magnetism is organized flowing of G1 particles. Charge caused by gravity, by a gravity field, not a field of mathematical, but a field of particles. Oh, I should put that in. Field of G1 particles, or G2 particles for nuclear force. Why do nucleons stay together? Because there's a gravity, particles way down at c squared. So there you go. And you then go and you fill in those things. Well, can you describe the double slit? Can you describe lasers? Expansion tectonics, do you have a mechanism for that? And you just put in the things for whatever theory. So you can go in and find somebody's theory and come in here and write about it and fill it out, get a picture of them. Voila. You add it to it, and it is a theory, and you can view the theory. And of course, I don't have these things displaying yet, but I'm going to make a table of a comparison of them all, so you'll know which ones are ether theories. You'll know which ones are use infinity, which ones don't, which ones have ultimate particles, that kind of thing. So the idea is you will come in here and fill those out. Scientists are the same thing. We need to put in the scientists. We got to go in and write about these people. I've already written about some of these very well, and of course there's their work already there. It's already there. We put them in the database. They're already there. You can read more about it. We have his Wikipedia entry. So, and we're asking people to fill out their Wikipedia stuff. If you are a scientist doing your own stuff right now, you're listening to me right now, we need you in our database. We need you in our wiki. We catalog all of this so that people can learn and come and learn about this. So if they come to Science Woke and don't know anything about the idea that things are wrong in mainstream, then they can come here and say, start here. That's what you say. And we'll say, this website has been put together with the purpose of leading you to become a Science Woke. This page will help guide you to that step-by-step. Blog articles to the ready. Here are blog articles we encourage you to read first, and in this order. Becoming Science Woke. Scientific revolution is here. Why mainstream can't see this revolution. All these things we try to take. I'm doing it, but I need help. So anyways, pretty cool. So go back to the questions. Need help. It's odd that I think Thornhill is very smart, but I wish they'd have different frontman. Frankly, no need to comment on that. Yeah, you know, it's a different group. It's a different group of people who, you know, but I've come to, you know, before I was thinking, oh man, there's a lot of I disagree, but then I thought, wait a minute, we need to support each other, because the most important thing is to allow models, different models, to exist all the time. We should not be in a Thomas Kuhnian cycle. We should be in a point where all models, everything can be questioned at all times. And if someone wants to come up with a new model, do it. Make it better. Yeah, you're going to have to pass the test. People are going to have to believe you. But we should not discourage that. If a student comes into a university and wants to do a completely new model, let them do it. Can't do it right now. You'll be kicked out. We have people being kicked out. All right. Oh, we got somebody else, Andrew Peacock. If Doppler medium refraction index is lower than the Proteus number, then what is the angle of dissidence? Why are you asking that question? Is this a question for me to show that, Dave, you're not a physicist? Is this a serious question? Is this a rhetorical question? Is this a mocking question? I don't know, Andrew. I will answer it. Maybe he's not there anymore, but it doesn't sound, I mean, Doppler medium refraction index is lower than the Proteus number. Then what is the angle of dissidence? Are you, again, how about this question, Andrew? What's your model for light? How does it physically work? And how does it turn into a rainbow? Let's just take the simple thing that took us 1.5 years to figure out with our model. Won't we talk about that? Again, I don't want to be assuming that this is sarcastic, but it certainly sounds so. And if it's calculations you want me to do, I don't need to do that to show anything. It's not what your titles are or what your ability to calculate is, it's what you say. And I always, in my movie, it took me 8 years to come up with the saying, don't listen to me, listen to what I say. What does that mean? Titles mean nothing. If a person has the ability to say, if this were not true, we wouldn't be worshiping Einstein at all, because he didn't have any titles when he started. So, and he didn't have references in his paper. But somehow he's okay. So, Andrew, you can come back at me and say I'm full of it, that you were asking a legitimate question, but some of those things, I don't know if you're just asking me the calculation of incident of refraction, reflection, and dispersion. Yeah, well, I don't think that's necessary for everybody to have us go through calculations like that. It is not a gamble to be nice. This life ultimate roll of the dice. Brazilian people as poor as you can think, only if you are a politician. Politicians here, yeah. Brazil is magnified. Everything that's a problem today, which is income inequality, where we have a ridiculous amount, small amount of people with almost all the wealth in the world. We're ready for a revolution. It's happening here in the United States. The progressives, people who care about people, who are running, who only work for the people, are now winning across the United States. Millennials, great going. Go Bernie and all his people. Again, I respect anybody's political position. I just think we need to care about other human beings more. David, I think you could make a fortune if you teamed up with a toy maker and have expanding Earths model. Yeah, well, actually, one of the things was to use Google Maps and have the 3D model of the Earth actually expand over time and allow you to plot things over it, so you can plot flora and fauna. Now, who's done this is James Maxlow. Look him up. James Maxlow, one of the greatest probably, in my opinion, the greatest geologist of all time. That's my opinion. I was disappointed with the last Saturday conference because it was just mostly Franklin talking about pseudoscience book. It wasn't really, yeah. Well, one of the things we're trying to do with the video conference, I'm going to try to get them more on track of having people talk about different things, because they're sort of keeping it alive, but I can't do everything. That's where we need help. We need to line up more people to talk so we can have a person come in and give a talk on it. That's really what we need to do in those. Right now, there's just sort of ramblings, and they stay that way. And I appreciate all their effort and all that, but we certainly need to get people lined up for that. I can't do it all. I need help of people. That's why I have, in that one group, I have our mornings. In fact, I put him down. You have to have people, and we have to almost prohibit some people because, Franklin's talked enough. We need to have other people talk. We have Bill Lucas has talked a lot too. We knows his stuff. We need other people in there to talk as well. So I agree. It's something we're having to rework. I've heard recently that H2O is not water. What do you mean when you say there's a different things than for? Good question. Let me go to our website with the guy himself who will be receiving the award for a Lifetime Achievement Award. Let's go to our website, and I'll go to the conference. This is actually live, so people don't know because I haven't announced it yet. But let's go to that. Here are the conferences, and I'll click on this, and here we go. Here is our big poster and our dog barking in the background. All right, I think we got it good there. A little bit. Let's see if I can move it over here. I'm over here. Let's see. I think I can do that this way. Move it like this. There we go. And it pumps down there. Come on. It's going to bounce back and forth. Okay, that's good enough. Here we go. Critical Thinkers Conference. And here he is, Dr. Gerald Pollack. If you look him up, Dr. Gerald Pollack, Lisa, got great videos. You'll enjoy them immensely. Basically, let me just explain. You have water liquid, you have water gas, and you have water ice. Turns out there's another form of water which they call easy water. Okay, I'm going to mute myself so I yell at my dog. Sorry, I had to yell at my dog. Sorry about that. It's nighttime. I don't know what they're yelling at. But anyways, the fourth form of water they call easy water. And the best way to think about it is the easy water is found, and that's what water turns. It doesn't turn into H2O. It's H3O2 or something like that. Look it up. Watch his stuff. Don't quote me on it, but they turn into hexagonal rings, and they only can exist in certain areas, what they call easy, I guess, zones. They call them easy zones. So if you look at the top of the water, you notice it beads, and then like you put something, you can even put a coin on it if you're careful enough. You're setting it on easy water, which are lattices of hexagonal lattices of water. They've got proof of this. And that fourth part of water, that fourth state of water, is the reason you can ice skate. Is because it's the fourth state of water. On top of the ice, you have the easy, and it also is super important in cells, in human cells, all living cells. Absolutely fascinating. The guy was crucified. This isn't even like telling you that Einstein's wrong. This is like, it's another, you can see it. But believe it or not, this was like controversial. He gave talks at our conferences 10 years ago. We invited him. He's an amazing, he calls fourth state of water. And he also talks about scientific activism. And this is really tough for him in the university. He is a real rare bird. So this guy is just absolutely great. We're going to have him talk. I've talked with him on the phone this year. He's a super guy. He's talked at the Electric Universe because he talks about the electric field and stuff. He's sort of in that camp as well. That's okay. His work is absolutely fantastic. Look him up. Look him up. I will talk about his stuff. So, very good. Let's see. I heard recently H2O, water. What are you talking about? Yep. Okay. Hopefully that answered your question a little bit. Look him up. He's all over the web. Dr. Gerald Pollack, Water, the fourth state of water. He's got a great book. Buy his book. Buy an ebook. Buy it. Buy it. Yeah, the site looks easy to navigate. It absolutely is. I'm working with people. The good thing is, Greg, is I have enough people from our own organization who give me great input, especially on Science Woke, because I had criticalthinkers.info, and I also came up with the idea of Science Woke thanks to Lisa. Thank you very much. I sort of had it in mind, but she really bopped it forward when she goes, you know, I always thought maybe science had the same problem as politics and the ecology and in the climate and economics, that whole thing. Isn't big science also pulling the wool over our eyes? Absolutely are. So that was cool. I'm positive I've seen some of his vids. Yeah, absolutely worth it. Okay, so how are we doing? I mean, I've been going on, oh my gosh, an hour and 40 minutes. Wow. I have more people. I want to really thank everybody for coming on. If you have some more questions, let me see if I can find this and see how we are now, how many people are watching. Throw this out. For some reason, I don't know if I get a count on my live page. Let me see. I'm trying to find it. Yeah, I don't see necessarily how many people. That's weird. I do have peak concurrent. I mean, we had a peak of 13, which is pretty good. That's better than way before. That's our best so far for 2,500 people. That's really good. Yeah, I'm in bed, but hey, of course, thank you so much, Lisa. You know, I got subscribed to your channel as well. Checking you out, saying who's crazy enough to watch me. But you find out I'm not too crazy. My question up there, okay. Proto-X, all right. Let's look at Proto-X. Question. Whoa, way up there, huh? In particle model, there's a description of how interaction works. I'm currently interested in symmetry of interaction. You know, I'm not sure. I'm not sure what you're meaning really by interaction. I mean, the only interaction we have in our particle model are two particles hitting each other, and we can describe the whole universe that way. I'm not sure what you mean by interaction. Can you? I know there is. I need to have some time here, so you probably takes a minute because it takes a minute to get to because it's delayed so much because of the pushing and pulling from OBS to this. So hold on. Let's see if I can get that there. All right, it's got the red dot. There it is. Live. Turn it down. We've got 10 watching. Thank you guys. Appreciate it. So I'll stay here. So if you can explain what you mean by interaction, ProtoX, você pode explicar exatamente o que você quer dizer com interação? Porque a gente só tem nosso modelo, só objetos que batem em outros objetos. E a gente pode descrever o universo inteiro com isso, cara. So, my Brazilian guy, trying to, you know, keep them there. So 11 watching, great. Well, welcome all of you. If you're new to this channel, you want to make sure you do want to hit subscribe below. The idea is to get people science woke. In fact, like I said, thousands and thousands of scientists outside of the mainstream. We've got people, our head person's from MIT she has a degree in physics and special relativity from MIT. And she's in a group that argues against relativity, the Big Bang, and all those things. So we are growing. In fact, I will tell you the truth. In my opinion, we are the silent majority. I think most people do not buy theoretical physics. Almost all engineers look at theoretical physics and strings and multi-dimensions. It's like, wake me up when it's real. So that's what this is about. What makes this, I think, people attracted to my conversations specifically, because that's why I started this channel, because I'd be at parties, would be with my friends, be at lunch, and they asked me about this stuff, and they would sit there for an hour and a half listening, is because we have real answers. We will tell you when it's wrong. We will tell you why the language that you're using is wrong, that the whole thing, I mean, we have been around picking apart and finding the problems with the language of physics, the language of cosmology, the philosophy behind it, the basis, the assumptions that they never tell you they have, but have, and all the problems there are with those assumptions. So, and we get answers. So we give people real answers, and they're going, wow. You know, that was one of the biggest comments I got in the beginning of this whole thing. And oh, I've got to share an email with you. Let's see if I can do this. I appreciate it. I actually have another email. I promise I'm going to share that email with you in another live session. I got one of the most I read this email at the conference, but I didn't record it because it was a private email. I got it from 17-year-old students in physics from Tibet, Nepal. And I choked up when I read it. And I get choked up when I read it again, because it really makes me think we're doing what we need to do. This is mission that we have as our organization, as this channel that we're doing, as the website Science Woke, is actually something very important to do. And I'm going to read you one that I got just yesterday or today. Quite amazing. I'm going to read it to you. I won't show it to you. That way I won't get into trouble. Here it is. I'm going to read this to you. Very nice. It says, Dear Mr. David, after my best greetings to you. Okay. His native language is not English. I think it's Farsi. I'm not sure. First, I would like to commend you on your work you are doing. Please continue your excellent review of mainstream science. I think that your work is a clear example of the description of Thomas Kuhn in his famous book, The Structure of Scientific Revolution, which I have an article on, exactly my second article that I have everybody read. And it has always been people like you who starts a paradigm shift in mainstream science. So thank you very much in sharing your views in the public. First of all, it isn't only me. I'm just out there putting it out there, and I've had it so many years, and I've become good at doing that. I'm just doing a favor to all the great scientists who I admire. So it's not me. It's the entire community of great people. Around 7 years ago, I wasn't as critical to mainstream science as I am today. You got to listen to where this guy is. I thought that everything we learned in school was correct, including relativity. Yet, in spite of that, I had a feeling that there was something wrong with quantum mechanics and general relativity. I did not think that time that the whole relativity thing was wrong as I do now. In 2011, when I was naively a relativity worshiper, puts that in quotes, I wrote a very small, yet what I think an important new idea on a personal blog. I thought that I could have a response from any physicist. Yet no one even bothered to take a look at it, except one single American gentleman who was outside the mainstream, meaning maybe one of our members. Here I send you the link to that short article. If you have time to look at it, I would find it helpful to your great work. I did take a look at it. I'm not going to talk about that today because I just got it. I need to read it a couple of times. I never read it only once. So he gave me a link. I did, and this is the part that's I find amazing. Well, it's all amazing. And I do get emails like this. If you did not have the time to see it or to send any reply, I will understand that I appreciate your kindness to have the time to read an email from an ordinary person like me. Says, it might also be important to inform you that I'm watching your videos in a highly unexpected place on this planet, namely Iraq, a country torn up by wars, terrorism, and corruption. Yet at least you get one big, okay, I think it's at least, he missed an S. Yet at least you get one big fan there, another reason to keep doing your great work. And signed, sincerely, Omar from Mosul, Iraq. I mean, I get emotional when I get those things. It's really, makes me feel like, sometimes I think, gosh, I got to do this again. What do I do? It's seeing people and being able to find their tribe, finding people with actual answers who are not afraid to question things. And actually, we have people in our database from over almost 80 countries, including Iraq and Iran and African countries. We have actually one gentleman from Nigeria comes every year, super scientist. I love him. Musa, great work. He's teaching young Nigerians, kids, boys and girls, to be critical thinkers. It's just amazing. This is a revolution we have, and a scientific revolution. So that's pretty cool. And I'm going to share you another one that's even more amazing than even this. But Omar, if you end up watching this or you're watching this at all, thank you so much. I will definitely go back and read your stuff again, but this was only 10 hours ago that I got this. And I've got other emails, and I need to share those, I think. That's pretty cool. So it makes me feel like, we're doing something. And, help is always needed. The good thing is you can help. Oh, here's one thing I did want to say about, I do have a video on Basecamp, that one video I showed you. And there I talk about something very important. You can help us 30 minutes a month, 15 minutes a month, 10 minutes a month. You don't have to spend days. You don't have to make huge commitment. Sign up for Basecamp, pick off something and say, hey, I need, I'll help out. What can I do? I'll give you a task. When you get to it, you do it, If someone else does it, okay. But if everybody just did 5 minutes, we have over 300 members. We have 300 active members of our organization. Not we have 800 around the world. They're not always active. Some of them are dying off. Many of the people in our group are retired. Why? It's because they couldn't make a living at doing dissident work. They couldn't be dissidents at their universities. They couldn't be dissidents at their jobs, like the NASA guy, like Dr. Edward Dowdy. He retired early so he could work on his work. So it's quite amazing. Yeah, it's emotional that unfortunately Lisa made a comment. I will make this political comment. I am not proud of my country, of what we do around the world. You know, bombing people is not the answer. People are people. It's unfortunate. People who are greedy, who want to make money off of war and don't care about human life. I will tell you one thing. I'm out there. I am voting for people only who work for people, who work for peace, who will take all that money. If we took all the money we spent on military here, I could be starting a Chappelle University totally funded by our government, of critical thinkers, of science woke people, of kids making their new theories, working on all these new theories and competing. That's where we could be. But we spend our money on stupidity. We even spend it on, you know why we have the Large Hadron Collider? Why we spend billions of euros on that? Because countries are worried about someone getting the next nuclear bomb or the next Higgs bomb or whatever it is. They're not interested in real science. Sorry. Off my pedestal. But any more questions? Because, man, 11 people watching. Please, if you have any questions. I mean, I'm going to go for 5 more minutes and then I'm going to cut it off. But I do appreciate it. Again, help, sign up, send me an email. Hey, Dave, I want to help. You don't have to commit. You can just go in there and find out you're going to do once 3 times a year. You're going to help out for 5 minutes, 10 minutes. It's a great thing. It's like picking it off a little bit of it every day. Do a little bit every day. But I will be giving I'll be coming out with some more videos between these sessions. And I do really need to start a video session. I can see I need to start. I've been, I've got another channel. I got lots of channels set up, but one channel I need to start doing is our particle model. Just talk about it. In my opinion, it's the most complete model out there. It's based on Borchert's stuff, which I think is great. We can't break it. We have one thing that came up. My dad showed me a video yesterday, and we're having to hack it. We're the cathode ray tube, where the rays going, and the rays, and this would be again G1 particles or electrons. To us, it's the same thing. So they're coming in, and you put a magnet, and it deflects it. We know that's how televisions, old tube televisions work, but you have to be able to explain that in our model. And it's really interesting because on the negative side, I'll leave you with something here. My father sent it to me. This will be my last thing. This is one of the, here, I'll show you how we critical thinkers are hacking the model, hacking the universe with our new model. So I'm going to show you this video and show you what we critical thinkers think. My last thing. This is going to be cool. Maybe I'll start out this is what I'll do. I'll start out my next video with this and talk about the particle model in my particle model. So I will get to this one and I will show it to you right now. Let's get to it. Get this other stuff off because it'll go faster because it's going slow. Got too many ones up. Here we go. Get past the thing and we will go skipping it, and 3 skip it. I can now skip it. Now I will go to skip ad. Come on, come on, come on. Here we go. Alrighty. So I'm going to show you this. There we go. Now I'm going to go about here. Alright, he's going to take a magnet here. Watch what happens. Come on. There we go. Okay. deflection because the electron, so it's a negative negative, taking the negative side of the magnet. Now when he goes further, now he does, look what happens. The positive side gets a completely different reaction. It doesn't bend up. And actually, my dad said if you look at the magnet, you'll actually see the beam go up and hit the magnet. It actually hits the magnet. Watch. Oh no, that's the negative side. When it goes to now go to the positive side. He's going to turn around, and it's going to actually be completely different. It's going to come out of it. Nope, he's not doing it. Okay, come on, turn it, turn it, turn it. Come on. Because he's doing that one because it's nicely done. Because I don't think he likes doing the other one because it really gets messy, and he probably doesn't have any idea why. There it is, right there. See? That's the other side of the magnet. Let's go again. Now I also want you to watch the end of the magnet. It lights up. It's going right to the end. My dad and I can explain this stuff. But we're still hacking this one a little bit. So anyways, that's the end for today. I think that's good. That's 2 hours. I want to thank everybody. I know they're dropping off because I know I am been here. But I do want to thank everybody for their support and inviting people here. Lisa, I know if you're not even here, that's fine. But all of you, muito obrigado, brasileiros. Eu não sei por que vocês estão chegando aqui, mas eu estou super agradecidos. Puxa vida, é grande honra para ter vocês aqui. Adoro o Brasil. Eu sei que o Brasil tem problemas igual aqui. Gosto de samba. Cantei no sambódromo com o Neguinho. Beija-flor, esse gringo, hein? Mas eu adoro o Brasil, eu tenho cientistas que admiro pra caramba lá, brasileiros, os cientistas que eu conheço, eu tenho muitos fãs, tem nosso modelo de partícula muito bem feito. Se vocês acham que a gente pode ter um grupo só em português, se acham que eu vou ter uma audiência para isso, eu não tenho problema, que eu falo português fluentemente, pelo menos eu acho. Sou carioca da Clara, não da Gema, não. Eu inventei essa frase, mas parabéns para vocês por ter vindo para cá. Eu sei que vocês falam inglês muito bem. Thank you so much. Talk with my Brazilian friends, say, hey, you guys want to get a group in Portuguese. That would be great. Thank you, thank you, thank you, all my subscribers. I will continue to work on this and help. If you want to help out, go to Basecamp. Be happy to have you there. So I will turn us off over here. Stop streaming. 2 hours. And remember what I always say in my sign-off. I always say, stay critical, stay thinking. I am David D. Hilster. I'm your science therapist, getting you to become science woke. Ciao for now. You notice the Portuguese and English there, eh? Você gostou, eh, gente? Ciao for now. Inglês, português e rima.